In this problem, the potential energy of any particle is given by this equation, where x is the position. Find the values of x for equilibrium and mention the type of equilibrium. Okay, very good. So to find the equilibrium point, we must do du by dx is 0. Okay, so first we do this. Du by dx is 0, u equal to this. So we simplify this. This comes out to be this, and finally these are the points where du by dx is 0. Okay, so these are my equilibrium points. So now let's check the sign of the double derivative d2y by dx square. So the double derivative will be 3x square minus 1. So at x equal to plus minus 1, at x equal to plus minus 1, what will be the value of 3x square minus 1? Okay, this will be 2. At both plus 1, x equal to plus 1 and minus 1, the value of d2u by dx square is 2, which is greater than 0. Which means x equal to plus minus 1 is a point of stable equilibrium, whereas at x equal to 0, the value of d2y by dx square is minus 1, which is negative. So if it is negative, then x equal to 0 is a point of unstable equilibrium. I hope this is clear. Let's go through this once again. If the sign of d2u by dx square is greater than 0, then it gives a point of stable equilibrium. If the sign is less than 0, it gives a unstable equilibrium, and also if d2y by dx square is 0, it gives neutral equilibrium. Here there is no point of neutral equilibrium, but in other problems or other cases you can find a point of neutral equilibrium as well. Thank you. In the next videos we will discuss some more problems on these topics. Thank you.